Hello. Our objective today is that we're going to find the area between two functions using integration. This is a pretty basic but important idea. To find the area in between two functions, we just use something that we've already been doing. So we know how to find the area underneath one function. So this red that I'm putting in right now is the area underneath f of x, and the green that I'm putting in is the area underneath g of x. And if you want that area in between them, you could just do the red area minus the green area. So this is going to be a really basic but important idea here. So the way we do this is we set up an integral that goes from the left to the right, so the lower limit to the upper limit. Notice these are x values. And then we just do whatever the higher function is during that time. So in this case, f of x, minus whatever the lower function is during that time, which would be g of x dx. So this is the basic idea. We go from left to right, that's our lower and upper limit, and then top minus bottom is our the two functions that we are subtracting inside the integral. For an example, let's take a look at this one. We would set this up as an integral. The area of R would be an integral. It looks like, let's see, that shaded area goes from 0 to a. Our upper function is this function during this time, so that would be g of x, minus our lower function during this time is down here, f of x. So our integral is integral from 0 to a, g of x minus f of x. If you can set these up, after that everything is just everything that we've learned before. A slightly more complicated problem would be when they don't give you limits. So find the area between this function and this function. So these are both parabolas. I assume they intersect twice. We could graph them on a calculator. They probably look something like this, which means we're finding an area that looks like that. And in order to do this, we first need to find where they intersect so we know where our limits of integration are. In order to do that first, we will set them equal to each other and solve. So I'll say 3x squared minus 1 equals 2x squared plus 3. When I solve this, I'll know the points at which these functions are equal to each other. If I subtract 2x squared, I'll get x squared and add 1 to the other side, and I'm going to get 4. So it looks like our limits are plus or minus 2. So we know our integral, we'll get back to this in a second, we know our integral is going to be the integral from -2 to +2. Second, we need to determine what our higher and lower function are. So in order to do that, we pick a value in between our limits, easiest one you can choose, so I'm going to choose 0 right now, and just plug it into the functions. We'll see which one is higher. So I'm going to find f of 0, and I'm going to find g of 0. When I plug it in, I get f of 0 is -1, and I'm going to get g of 0 equals 3. I did not have to choose 0, I just had to choose something in between -2 and 2. Clearly, g is higher than f at 0, so this is the upper function and that's the lower function. I'm going to strongly recommend you always use parentheses here, even if you don't need to, because of that subtract that we're going to use. So my g of x function is 2x squared plus 3, minus my f function is 3x squared minus 1 dx. I'm going to simplify this before solving, but at this point we're kind of done with the picture part of it, and now we're just in integration. So we're going to have an integral from -2 to +2. When I combine all this, I'm going to get -x squared and then plus 4 dx. That integral is -1/3 x cubed plus 4x from -2 to 2. And I know I'm running out of space, but we'll get there. Plugging in our upper limit, we have -1/3 times 2 to the third plus 4 times 2, minus our lower limit is -1/3 times -2 to the third plus 4 times negative 2. And if this was an AP exam, we could leave this there, but I'm going to type this in really quick. And let's see. I'm kind of wondering if this is going to come out to 0. Which does happen a lot if this was symmetric. It usually would. But I got the no, it doesn't. So this ends up being 32/3. So thank you for waiting while I type that in, and that is our integral.